Any question about paths through a network? No matter how much data you're given or verbal description, the best thing to do is to draw it. This particular question is a very good example of that. A project consists of 4 tasks, A, B, C, and D. Task A must be completed before task B and C are started. Let's just need to draw this. Okay, every project begins with a starting node. Task A must be completed before B and C are started. A is here. When you've finished, B and C can start. And then what else does it say? Task C must be completed before task D is started. Here's task C now. When it's completed, task D can start. I'm just representing that particular relationship. Then there's no more information. Now wait. Every network begins with a starting node, and now that I have the tasks here, I do need to connect it. I wanted to connect it to all the tasks that essentially have arrows leaving them, but no arrows pointing at them. B has arrow pointing at it, C has an arrow pointing at it, D has an arrow pointing at it. A, obviously, is the one that must be at the start, but that's actually how you know for a fact. If there's ever any question who should be connected to the starting node, then to finish this particular diagram, we do need to draw an ending node that represents being finished with the project. Now, who do we connect here? We connect any task that has arrows pointing at it, but no arrows leaving it. And I see 2 of them, B and D. Now, why is it so important to draw a start and an end? Because what was this question actually about? How many paths are there through this network? We remember that a path is any complete route from start to end, which is why that we needed, even for a small network like this, a starting and an ending node. Okay, how many different ways can I now get from start to end? Well, let's see. I can go from start to, just follow the arrows, A to B, and there's a way to get to the end. So that's one path. Matter of fact, why don't I record that? Path A, B. Versus at the start, what else can I do? I can go to A, then to C, then to D, and then to the end. That's a route. So that's another path. And then this is a very simple network. There isn't any other route from start to end. That's the answer to the question. There's 2 paths through this particular network. Now, one of the things that's handy is the question after that, if you look at the verbal description, is describing the exact same project. A project consists of 4 tasks, A, B, C, and D. There they are. Task A must be completed before B and C are started. Task C must be completed before B, D is started. Yes, we knew all of that. Oh, except this follow-up question adds some information. Each task takes 1 day to complete. What is the duration of the project? Now, with this particular question, I'm going to use the network we already drew. First off, you could find the duration of the project kind of like, the classic way in that what would be the next step here? We would find the early start, early finish times. We can do that. Find early start, early finish times. Begin at the starting node. Anything connected to the starting node has an early start time of 0. Okay, that would only be A. A has an early start time of 0. 0 plus 1. A at the earliest can be finished in 1 day. All right, B can't start until A is finished, so you pass the number forward. B could start at the earliest in 1 day. 1 plus 1, B could finish at the earliest 2 days from now. C is in the same situation, can't start till A finishes, so it could start at the earliest in 1 day. 1 plus 1 is 2. Then let's see, D. D can't start till C finishes, so D could start at the earliest, pass the number forward. 2 days from now, 2 plus 1 is 3. We've found the early start, early finish time for each of these activities. The question was, what's the duration of the project? Right, well, once you've found all the early start, early finish times, you go to the ending node, you see who it's connected to the end, and you look for the largest early finish time, because that would be the last thing that would finish. So you see here that your choice is 2 and 3. The largest is 3. So the answer is, actually the question is down here, 3 days. Okay, that's the answer. Though I wanted to point out really quick, in case you were interested, there actually was, for this particular problem, another faster way to work it. This particular project only has the 4 tasks. It only has the 2 paths. We knew that from the question before. We remember also that the duration of the project is the length of the longest path. This project only has 2 paths, so it actually would have been quicker to figure out what was the length of each path and to look for the largest number. And it would have been really quick since each one of the tasks is only 1 day long, so it's really easy to discern 1 plus 1 is 2. Path AB is 2 days long. 1 plus 1 plus 1. Path ACD is 3 days long. The length of the project is equal to the length of the longest path. There's the answer right there as well. So that's an alternative way of determining the length of the project.